and welcome to a video tutorial learning about solving word problems with linear inequalities. Let's take a look at a problem. We have a school that has a budget of $300 per classroom to buy workbooks. A math workbook costs $7 and a science workbook costs $10. If you want to buy 28 math workbooks, what is the maximum number of science workbooks you can buy? Write an inequality for this situation, solve it, and graph it. All right. Well, let's get into this. The first thing I want to do, I love to do with any sort of word problem, and if I'm going to try and use algebra to define it, I need to define my variables. So let's figure out what do we want x and y to be in this problem. All right, well, let's find that question that we need to answer, right? What is the maximum number of science workbooks you can buy? So apparently I need to keep track of how many science workbooks I'm going to buy. The other thing that's changing is the number of math workbooks I buy, right? It tells me specifically 28 math workbooks, but if I'm trying to write an inequality to kind of in general represent the whole situation, let's let x equal the number of math workbooks that we buy. And let's let y equal the number of science workbooks. Workbooks, there we go. Okay, good, we've got our variables defined. Now we can start to piece together this inequality. Let's look at the key information, underline it, figure out what we got going on here. A school has a budget of $300 per classroom. So what does that mean? Well, budget means that's how much money we're given. I can spend up to $300. I could spend less. That might make somebody happy, right? To not maximize the whole budget. But it basically means I can spend anywhere up to a maximum value of $300. I can't spend over that. So that's my inequality. Something's got to stay less than or equal to 300. I can't be more than that. It could equal 300. I could use it all up. It could be less than 300. I don't have to spend it all, but I can't be more than 300. Okay, there's a good piece of information. A math workbook costs $7. So it's $7 for each math workbook. So I'm probably going to have a 7x somewhere. And a science workbook costs $10. So it's $10 for each y variable, science workbook. All right, that's enough to put it all together then. All right, so we're going to have each math workbook costs $7, and I purchase X number of them. So 7 times X is going to be how much money I spend on all the math workbooks. I add to that spending $10 for each science workbook. So that's the total amount of all the money I spend on science workbooks. If I combine those two together, I have to stay within my budget, either less than or equal to $300. There's an inequality that represents this situation. Okay, let's go ahead and solve this thing out now. What am I going to try and solve? Well, in particular, remember, we're told specifically we want to buy 28 math workbooks. Maybe we want a classroom set. We got 28 students. If I spend my money on that, what is the maximum number of science workbooks I can buy? So we're taking one variable, the number of math workbooks, and we're setting it to a specific value. We're taking x and saying, okay, x is going to be 28. It's going to be locked into that value. And we're asked to find, well, how many science textbooks can I buy? I'm asked to solve for y. So there we go. So let's rewrite my inequality. I'm going to have 7 times 28. If I buy 28 math books, how many science books? I'm going to solve for that y variable to still stay under my budget of $300. That's what I'm going to solve out. Let's go ahead and do that. Let's draw my little line down. Let's solve this inequality out. So first thing I need to do is 7 times 28. That's going to be 196 plus 10y has to be less than or equal to 300. So if I buy 28 math books, that means I'm going to spend $196 on all of that. All right, now let's subtract out the $196 I spend and see how much is left over. That goes to 0, so I'm left with 10y, $10 for each science textbook, and I have 300 minus 196 is $104 left to spend. Okay, let's divide both sides by 10 to find out what y needs to be. So y has to be less than or equal to 104 divided by 10 is just going to be 10.4. All right, I just did the algebra. I solved my inequality. How do I interpret this now? Y is less than or equal to 10.4. That means the number of science workbooks has to be less than 10.4. Unfortunately, I can't purchase decimals or fractions of science textbooks. So the maximum number of science workbooks, the maximum number of science workbooks is going to be 10. I can't buy 11. 11 is not less than or equal to, so I have to do the nearest whole number that satisfies it. So I can buy 10 science workbooks. I could buy 9 or 8 or 7 or anything less than that, but the maximum number would be 10. So there we go. We just answered our problem. So there we go. We wrote an inequality. We solved it. We answered the question. The only thing left to do is just to graph it. I want to get just a nice little picture of all the possible solutions, all the possible combinations of science and math textbooks that I could get. Okay. Let's draw my axes. It's not a very good one, but we're going to freehand it, so you just got to deal. All right, so we've got 7x plus 10y is less than or equal to 300, and I need to get a boundary line and figure out where to shade to graph all the possible solutions. I'm going to go ahead and just find the x and y intercepts, just because that's really easy when it's in this format. So if x is 0, if I put 0 in for x, then I'm going to have 10 times y is equal to 300. If I divide both sides by 10, I end up with a y-intercept of 30. 300 divided by 10 is 30. So I'm going to come up here and say 10, 20, 30. There's my y-intercept of 30. So I need another point to draw a line, so let's find the y-intercept. Sorry, no, the x-intercept. Let's set y equal to 0, which means now I've got 7 times x is equal to 300. If I divide both sides by 7, I get a really ugly decimal, but to the nearest fraction, it's going to be x equals 7 and 6/7. So if that's about 10, there's 10 right there. So 7 and 6/7 would be right about there. All right, that's enough to make a line now. Roughly kind of like that. There's my boundary line. I can go ahead and make a solid line because the inequality is everything less than or equal to. So any point on that line is considered a solution. So I can go ahead and make a solid line. If it was not equal to, then I would have to make a dashed line. Okay, now we need to figure out, well, which side represents all the solutions. Is it the left side or is it the right side? Well, here's where I like picking a point. The easiest one is just to use 0, 0. Pick a test point. If x is 0 and y is 0, is that true or is it not true? That helps you find the side that the solution is set. So if I do 0, 7 times 0 is 0, plus 10 times 0 is 0. Is 0 less than or equal to 300? Yes, yes it is. That's true. So the point 0, 0 has to be in the solution set. So I'm going to shade this left side of the inequality. Okay, now granted, keep in mind this is science workbooks, so I really don't care about negative values, do I? I only want to know positive values of workbooks. So really my solution set, let me get a nice purple color here. My solution set is only going to be all the positive values. It's going to be in this little triangle region here where y values are positive and x values are positive. So that's where I could zoom in. 1, 1, 1, 2, 3, 3 is probably all in the solution set. But anything with a negative x value or a negative y value is not going to really be a solution to this problem because I can't buy negative math books or negative science books. So my solution, all the possible solutions are going to be inside that purple region, less than the green line or equal to the green line, but still greater than 0 for both x and y. Okay, there you go. Hopefully that's a helpful work through of a word problem using linear inequalities to understand and answer the questions of this word problem.